I believe the live. Let me know chat if you guys can hear properly. Check as well. Yes, I can see. Let me know in the chat if you are able to. Yep, I think I can hear myself. So I think you can hear me properly. Let's wait for some time. Right. I think some people are in, so let's actually get started. First of all, I'm very sorry about the setup that I have right now. It's like I'm in a hotel room, so I don't have the green screen or the any proper place to hang the green screen and make up or make a proper setup. So that's why it's like that, and it will be like this for a couple of days more. But I'll try to sort this out as soon as possible. Other than that, let's actually start, like, without wasting much time. Let's actually start with today's class. So again, like, today we'll be discussing two more problems on that has been asked on Amazon interviews. And again, I'll be giving you a few questions for your homework. So yep, let's start with the first question. So today's classes will be more based on dynamic programming. So we'll be solving DP questions, right? And the homework will also be based on the same, like, dynamic programming questions. So I think this will be important because, again, like, in any interview, dynamic programming is one of the, like, favorite topics of the interviewers. So I believe, like, it will be very useful. It will be, like, very useful for you guys, and definitely, like, I might be able to help you in some way if you have some problem regarding dynamic programming, right? So let's actually start with the first problem. So the first problem we'll solve is, again, like, we'll be solving very standard problems today. We'll not be solving something that's not standard. So the first problem is a very standard or common question, which is the longest common subsequence. uh, Before that, I'll just quickly check if there's something in the chat. I don't think so. So yep, let's start with this. So we are given two sequences, right? We are given two sequences. Find the length of the longest subsequent present in both of them. And both the strings are in uppercase. So we are given two strings. We have to find what is the length of the longest common subsequence. Now, what do we mean by a subsequence? So a subsequence is a set of characters, like, it's not necessarily a a subset, right? So it will not, it's a subset, sorry, it's a subset, but it's not necessarily continuous, right? It's not a continuous set of characters. It can be discontinuous. It's just a subset. The only property of a subsequence is that the characters, the way we take the characters in the subset should be the same way they appeared in the string, right? Or in the array. So that means, for example, let's consider this a b c d g h, right? Let's consider this a b c d g h. Let me just adjust this a bit. a b c d a b c d g h. This actually, let's consider this a set of characters, let's say d c g, right? D C G. So the subsequence will be D C G. Sorry, B C G. Sorry, not D C G, B C G. BCG will be the subsequence. We cannot write it as CBG. That's a subset, right? That's a subset of characters, but they should be arranged in the same way they appear in the main string. That is BCG. And see, they are not continuous, right? Like, BC are continuous, but G is not continuous. So if it becomes continuous, it becomes a subarray. But as it is not continuous, it is called a subsequence. And they should be in the same order in which they appeared in the string. Now we are given two strings. We have to find the length of the longest common subsequence, right? So for example, ABCDGH, ABCDGH, and ABEDFHR. In this case, what will be the longest common subsequence? ADH, right? ADH. See, ADH. A is coming before D. H is coming after D. So ADH is a subsequence. ADH is also a subsequence in this second string, and this is the longest one. We cannot have a subsequence of length 4. So this is the longest one, and we have to return 3. That is the length of the longest common subsequence will be 3. So this is the question, right? Similarly, ABC, ABC and AC, A and C, after AC is happening, and here AC is a substring, so it's also a subsequence. Note that every substring is a subsequence as well, right? Every substring is a subsequence, but not every subsequence is a substring, because substring contains unique consecutive characters. Subsequent doesn't need to be consecutive. It can be consecutive, it cannot be might not be consecutive, right? So AC is a subsequence, AC here is also a subsequence, so the length will be. So this is the question length, and this is a very standard problem. So let's see how we can solve this. All right. So when we are given a DP question, right? Whenever we are given a DP question, or we can understand that it's a DP question, the first step, like we generally, or not we, but again, I prefer to explain it this way, or I prefer to think this way. It might be different for you or someone else, but again, like I prefer this way. So I generally break a DP question into three parts, like solving a DP question into three parts. The first part is identify the states and write a function that will basically solves the that's basically responsible for solving the problem. Now, what about states? What do we mean by states? States means the minimum set of parameters that you have to pass to understand what is the condition of the problem at any given point of time, right? So what can be the states for us? The states for us can be the substrings, right? It can be the substring that we are considering, like the substring from the beginning that we are considering. So let's call it S1 and S2. This can be a state, right? S1 and S2 can be a state. This is definitely a state. But again, like we generally do not consider arrays, strings, these things as states. Rather, we always prefer to have numbers as state, right? Because we can create arrays using numbers. Like we can definitely create an array like of size 30 or 40 like this, right? So we can use numbers to create arrays and index on arrays. So that's why we definitely prefer numbers to be the state, right? Anything that is numerical value, that can be a state. So in our case, how do we represent the state? So we have a function f that actually solves the problem. What will be the state for this? So what do we want? We want the substring for which we are solving for both the first and the second strings, right? At any point we will have a substring left from the first string and the substring left from the second string, and we want to basically find the longest common subsequence. So instead of specifying the substring, we can also specify their length, right? Because the substring will be only from the starting point, like we'll not take a arbitrary substring and compare. It's just a set of characters from the starting point. We'll always take a prefix of the string. So at any point of time n comma m, n is the length of the or the first n characters of the first string, and the first m characters of the first string, we are finding the LCS. So this will return the LCS of first n characters, of first string, right? First string and first m characters of second string. So what is f n comma m? F n comma m will be the LCS of the first n characters of the first string and the first m characters of the second string. So a way to actually identify the state is generally n is one of the states, right? So whenever you have an array of elements and you are finding some DP, generally, like I'm not saying always, generally n is one of the state where n is a subarray, a prefix of the array, right? The first n elements of the array. So generally n is a state, and we solve based on that. So here also we'll use the same logic, that is we'll take n and m. What does f n comma m mean? It means the LCS of the first n characters of the first string and the first m characters of the second string. That's the definition, right? The second step is generally to make an assumption that for a given value of n comma m, it is if n comma m is not calculated. So let's call it n comma m only. If n comma m is not m comma m, it is not, we do not know the value of n comma m, but we know the value of every other possible possible states, right? Every other possible values of this n comma m, we know the value, except for f n comma m, we do not know the value. N comma m here is a fixed value, right? You can definitely write it something like k comma l and some, or a comma b, something like that. But again, like just to write the recursion properly, I'm writing it as n comma m only. But again, like you can write n equals to a, m equals to b, something like that. So just fix a value of this state, and for that value you assume that you do not know the answer, or if doesn't return the value correctly, you have to compute it. For every other possible value of the states, if returns the value correctly. The third step will be to determine the value for this f n comma m, or the for this constant that is not like for this state that is not defined, for which f doesn't return the value correctly, using neighborhood values, right? So we have to compute the value of f n comma m. Now, what is n comma m? Again, let's revisit. What is f n comma m? It is the LCS of the first n characters. So we have a few characters in the first string. Last, this is the nth character. This is the nth character. Again, for the second string, we have a few characters here, and this is the mth character. So this is n comma m. What do we want? We want the longest common subsequence, right? So what are the cases? Just consider right now, just consider for the current state, what can happen with the nth character and mth character. The nth character and the mth character can be same, or they can be different. There are two choices. Nth and mth character can be same or different, right? So let's write it down properly. So if n comma m we are calculating, let's take the first case as a of n is equals to b of m. The nth and the mth character are the same for the first and the second string respectively. And the second case will be a of n not equals to b of m. This is the second case, right? So there are two cases. Now in the first case, if they are same, it is always better for us to match. It is always better for us to match, because we can match now or we can match later, right? So it's always better for us to match. So we'll do 1 plus, because 1 is added to the subsequence, 1 plus f of n minus 1 m minus 1, because we are left with n minus 1 characters from the first string and m minus 1 characters from the second string, right? Because from the first string we are taking away the nth character, we are taking away this character, we are matching this character with the mth character of the second string. So these two are matched. So what are we left with? We are left with the first n minus 1 characters, and in the second string we are left with the first m minus 1 characters. So 1 plus f n minus 1 m minus 1. Why are we always taking this move? Because you can match. Let's say there is a here. Here is also a. So you can either match this a with this a, or you can match this a with something later, or this a with something later here, right? It's always better to match, because anyways you will get the same answer, right? You will get same answer or better answer. So it's always better for us to match. So we'll always match. Whenever there is a match, we'll always match. Let's talk about the case when there is no match. For example, let's say this is here is a, and in the second string here is a b. This is not matching, right? So we will not discard both of them. We have to get rid of one of them, because these two characters are not matching. So we have to get rid of one of them, right? We have to get rid of one of them. Which one would we get rid of? So either we can get rid of this a, or we can get rid of this b. So this will basically go to that fact that if we get rid of this a, what are we left with? We are left with first n minus 1 characters of the first string. And what are we left with in b? The first m characters, because we are not getting rid of this b, right? We are not getting rid of this b yet. So f n minus 1 comma m, or we can get rid of this b. In that case, we are left with the first n characters of a, because this a we are not getting rid of yet, and the first m minus 1 characters of b, right? M minus 1 characters of v. So this is what we have. What do we want? We want the longest common subsequence, right? We want the longest common subsequence. Now what does this return? This returns the longest common subsequence for the first n minus 1 characters from a and m characters of v. This returns the longest common subsequence for the first n characters of a and m minus 1 characters of b. What do we want? We want the longest of them. So we want the maximum of them. So maximum of these two, right? So this is the final recursion that we obtain. This is the final recursion that we obtain, that the final recursion, let's write it down properly. The final recursion will be if nm it can be either 1 plus if n minus 1 m minus 1. This will be true when a of n equals to b of n. Otherwise it will be the maximum of if n minus 1 m if n m minus 1. It will be the maximum of these two, right? So that is the definition of f n m. Now the last step will be, this is, we have defined the recursion, right? And this was the most difficult portion. We have done this. Finally the last step will be, what is the base cases? Base cases are the cases for which you have to know the value manually. You have to write the value manually, because otherwise it will continue indefinitely, right? It will never stop. So you have to have some stopping condition for this to stop. So that is basically what a base case does. So base case, let's consider n comma 0. That is, what does f n comma 0 mean? What is the LCS of the first n characters from the first string and the first 0 characters from the second string? So there is no LCS, right? You are taking 0 characters. So 0. Similarly, f0 comma m, this is also equals to 0. So this is the base case, right? I hope you understand why it is 0. Because the definition, again, let's revisit the definition. What does f n comma 0 mean? What is the LCS? What is the longest common subsequence of the first n characters of the first string and first 0 characters of the second string? First 0 characters means empty string. What is the LCS? There is no LCS, right? There is no matching characters. So that's why 0. Similarly, 0 comma m is 0. So this is the base case and this is the recursion. So we have done, like, we are done with the problem. So we can just write the code for this. I hope that it's clear with you. Let me know if it is not. So let's actually quickly try to write the code for this. LCS xy, I think that's the length of the strings. So let's take a dp array, dp, put it to the side, dp x plus 1 y plus 1, dp 0 0. So let's run a loop for till the length. For int I equals to 0, I less than equal to y, I plus plus, dp 0 I equals to 0. Or we can actually initialize dp with 0, right? Dp entire array will initialize with 0, is equals to 0 initially. Entire array is 0 initially. Now what we can do, for int I equals to 1, I less than equal to x, I plus plus. We'll just write the recursion, right? So many of you are confused. Milind, I'll be taking the interview series. I have been really, like, I've been traveling this week and really busy, so I have not taken for 2 weeks. But don't worry, I'll be taking from the next week. So definitely I'll be taking from the next week. Don't worry about that. Anyways, one more thing that you generally have doubt with is, how should we write iterative? Like, I also struggle with this a lot. Like, we can form the recurrence relations, like we can definitely think about it and form it, but after we have formed it, how do we convert it to an iterative solution? It's easier to write a recursive solution, right? Once you've written the recurrence relation, it's easier for us to write the recursive solution. But generally people prefer writing iterative solution because it's faster. And how do we convert the recursive solution to an iterative solution? The idea is that you have to do nothing, right? What you have to do is you have to identify what are the states, right? You have to run a loop against all the states, like x and y are the states for us. So we'll run a loop for all the states. Now we'll just write whatever is there in the recursion, right? We'll just write whatever is there. So j equals to 1. See, how do we write it? J less than equal to y, j plus plus. So we have generated all possible states. All possible ij's are basically state. Now if s1 of I, if s1 of I minus 1 is equals to s2 of j minus 1, if the two characters are same, then what do? We match them. We have already discussed, we match them. What was the recurrence? Let's revisit the recurrence. F of ij, what was it? F of nm, it was basically 1 plus f of n minus 1 m minus 1. That was the recurrence, right? Here we'll just replace this with ij. So dp of ij is equals to 1 plus dp of I minus 1 j minus 1. Simple. See, I've written the same thing. Only in place of f, I've written dp. In place of n minus 1, I've written I minus 1. M minus 1, I've written j minus 1. Just one thing that you have to be have to know is what should be, how should the loop run, right? How should the loop run? Because if you see here, n depends on n minus 1. N depends on n minus 1. So the loop of I should run from front to back, because n minus 1 should be computed before m. Similarly, m minus 1 should be computed before m, so the loop of m should also run from front to back. So that's why we have written incremental loop for both I x comma y. So this is one part. Else dpij equals to max of dpi minus 1j dpi j minus 1. That was the second part, right? Just remember the recurrence again. F n comma m is equals to max of f n minus 1 comma m f n comma m minus 1. This was the recurrence. I've just replaced f with dp and n with I minus 1, n minus 1 with I minus 1, m with n with I, m with j, right? That is what I've replaced with. Other than that, everything is same. Only just remember which direction to run the loop. Let's say you have a dependency. You have a dependency like this, that the recurrence is something like this. N comma m is equals to f n plus 1 comma m minus 1. If the dependency is like this, how should you run the loop? For n, you should be running the loop backwards, because n depends on n plus 1. So n plus 1 should be computed before n. That means we should run the loop in reverse way. For m, we should run the loop forward, because m depends on m minus 1. So that is how you should run the loop, and this is the only thing you have to be careful about, right? So final answer will be return dp nm, xy. What is this? This is the LCS of dp xy, means it is the LCS of the first x characters of s1 and the first y characters of s2. That is the entire s1 and s2. That is what we want. So that is given by dp xy. So let's try to run this. Our output is weird, so let's actually, I think the base case is not working properly, so let's manually fill the array, right? For int I equals to 0, I less than equal to x, I plus plus. For int j equals to 0, j less than equal to y, j plus plus, ij equals to 0. Let's fill this. Okay, this is giving the answer properly, so let's try to submit this. Okay, so this is working, right? This code is working. Anyone has any doubts with this? Anyone has any doubts with this LCS? Otherwise, we can go to the next problem. Let me know if you have any doubts with LCS. Otherwise, we can go with the next problem. Any doubt on how to write iterative DP? How do we solve the LCS problem? Any doubts on that? All right, I think that you have understood, so we can move to the next problem. Let me know if you have some problem. I'll definitely try to explain again, right? So you are given, now we'll solve the another very common, like any very popular question, which is the 0 1 knapsack problem. So we are given weights and values of n items, right? So there are n items with us, and we are given the weights and values of these n items. Put these items in a knapsack of capacity W to get the maximum total value in the knapsack. Note that we have only one quantity of each item. In other words, we are given two arrays, vals and weight, which represent the values and the weights associated with the n items, right? Also, given an integer w which represents the knapsack capacity, find out the maximum value of the subset val such that the sum of the weights of this subset is smaller than or equal to w. You cannot break an item, either pick the item completely or don't. It's a 0 1 property. Okay, let me explain this in very simple words, right? Let's say there is a house, right? There's a house and the house contains some items. Each item has some price, that is the value of that item. Each item has a weight, right? Each item will have a price, each item will have a weight. Let's say a burglar enters into your house, right? A thief enters into your house. The thief is trying to steal some items. Now what does the thief want? The thief wants to get the maximum value out, right? If possible, he would take the entire set of items, but there's a condition. The thief is carrying a, let's say, a knapsack. A knapsack is kind of a rucksack or something like that. That a thief is carrying a bag, right? The thief is carrying a bag. The bag can only hold weight up to w. The capacity of the bag is w units. So the total weight of the items that he can steal should be less than equal to w. He has to determine what is the maximum possible value that he can get, provided he can leave the home properly. That is, he will take the items, and each item has one quantity, right? He cannot take an item 10 times. He can take an item only one time. Each item has some weight and some value. The thief is carrying a bag. The bag has a carrying capacity of w. It cannot carry a weight more than w. So he wants to maximize his profit, that is maximum value that he can take, provided the weight of the items he has taken doesn't exceed w. That is the condition. And each item he can either take or leave. And that's a 0 1 property. Like, you can either take the item or you can either leave the item. That's a 0 1 property, and this is called the 0 1 knapsack problem. So I believe the problem statement is clear with everyone and it makes sense. So for example, n is equals to 3, that is there are 3 items in the house. W is 4, that means the bag cannot carry a weight more than 4 units. We have the values as 1, 2, 3 and the weights as 4, 5, 1. So what is the set of items we can carry? We can carry this 1, we can carry this 5, or we can carry this 4. We cannot carry two items together, right? If we carry 4 plus 1 together, that weight would be 5, which would be more than the carrying capacity. So each item we can carry independent, only one. We can carry only one item. So we can carry the one, like 3 only. We can carry 3, and 5 we cannot carry because that is beyond our carrying capacity. So we can only carry this 4 and 1. Out of them, what is maximum value? 3. So we'll choose 3. So the output should be 3 here. Similarly, 3, 3. Maximum weight we can take is 3, and the values are 4, 5, 6. In this case, we cannot take any item, right? We cannot take any item. So we'll return 0 because all the weights are greater than 3. So this is the question. Now let's see how we can solve this. All right. So let me give another example, maybe just to make things a bit simpler for you to understand. Weight and let's call it weights and values, right? So values, weights and values. Weights will be let's say 3, 2, 4, 1, 5, 3, 2, 4, 1, 5, and values, let's say, will be 10, 15, 25, 23, rather 23, 2, and 19, something like this, right? So let's say the carrying capacity, maximum carrying capacity is let's say it is 5, right? So what are the possible combinations that can be taken? A possible combination can be this weight 3 plus 2, 3 plus 2. Another possible combination can be 3 plus 1, 3 and 1. Another possible combination can be this 4 and 1. Another possible combination is 5. So these are the only possible combinations the thief can take. 3 plus 2, what is the value? 10 plus 15, that is 25. 3 plus 1, 10 plus 2, 12. 4 plus 1, 23 plus 2, 25. 5, 19. So what is the maximum value the thief can take? either this 25 or this 25. So he will be taking one of them. So the maximum value the thief can take is 25, right? So this is the question. Now let's see how we can solve this. Again, the first step is to write a function and identify the state, right? So what shall be the state? Then we have an array of elements, right? So let's consider that the thief has already gone through a few items and a few items are remaining. So the thief has gone through the second set of items. Like here the arrangement of the items doesn't matter, right? If the thief goes through 1 2 3 like this, or the thief goes through the items like 3 2 1 like this, the arrangement doesn't matter. What matters is the total weight should be less, right? So the arrangement of items doesn't matter at all. So if n is, so we'll always choose in a, whenever the arrangement of items doesn't matter, we can always keep n as a state, because we'll assume that the thief is left with choosing from the first n items. Are the rest n items, let's say there are total number of items is capital N, so n minus n items has already been like decided by the thief whether to take or not. He's just left with the first n items, right? Now next is, we identify, is this state enough? Is this state enough to solve our problem? Let's say, is this state enough to solve our problem? Let's understand that. So let's say if a value of n is 3, so we are left with the first 3 items. And let's say in this case the carrying capacity left is 10, versus f3 the carrying capacity left is 20. The answer should be different for 10 and 20, right? Because in this case he has 3 items and he can carry maximum 10 units more. In this case he has 3 items left in, he can carry 20 units more. So definitely he can get better value from this, right, than this one. So the state is not enough. It doesn't uniquely identify every possible combination. So we have to introduce another state, that is W. What is the amount of weight remaining that he can take, right? So what is f nw? It is the maximum value we can get from the first n items. Maximum value we can get from the first n items, provided we can carry W units more. So max value, so if n comma W is the max value that we can get from the first n items, only first n items. N doesn't mean all the entire array, it means the first n items. N can be 2 3 anything, provided we can carry W units more, right? We can carry small w units more, right? That is the definition of fnw. So what is the answer to our problem? The answer to our problem will be if capital N comma W, first capital N items, that is the entire array. What is the total number of maximum value that we can get from the total entire array, provided the knapsack has a maximum weight of capital W, that is the total weight the knapsack can carry. So that should be the answer to our problem. Okay, now this identifies the answer. Second part is fix the value of nw. So let's just keep it n comma w only for now. The third step will be try to determine this value of n comma w. Now determine this value of n comma w. What does this mean, right? Let's understand this. So we are left with n items, right? We are left with n items. This is the nth item, right? F n comma w. Now what we can do, and we can carry a weight of W more. So what can we do with the nth item? We can either take this item or we will not take this item. We can either take the nth item or we will not take the nth item. So if n comma W, if we take this, what are we left with? We are left with n minus 1 items. What is the more weight we can carry more? We have taken the nth item, so W minus W of n is the weight we can carry more. We have to subtract the weight, right? Because we have taken the nth item, so we have to subtract its weight. But what does f n comma m return, n comma W return? It returns the maximum value that we can get. What does this return? This returns the maximum value from the first n minus 1 items with this weight. But we have taken the nth item also, so we should add its value as well. So the plus the value of n. So if we take it, if we don't take it, we are left with n minus 1 items, and we can still carry a weight of w because we have not taken the n minus nth item. So f n minus 1 w, and we want the maximum out of them. We want the maximum out of them. Only one corner case will be when we cannot take the item at all, like when the weight of the item, when the weight of the item, nth item, is greater than the current weight that we can carry w. In that case we cannot take that item at all. In that case we will just go for the second case, that is will not take it, right? So that is the recurrence. Let's write it down more formally. So f n comma w is equals to the maximum of f n minus 1 w minus weight of n plus value of n, comma f n minus 1 w, and this is when weight of n is less than equal to w that we can carry. Otherwise it is f n minus 1 w otherwise. So this is the recurrence. Let's talk about the base case. So in the base case f0, let's say we are left with 0 items and we can still carry a weight of w. In that case, the maximum value we can carry is 0 because we don't have any item left. Similarly, if let's say we have n items remaining but we cannot carry any more weight, 0 weight, so in that case also we cannot choose any item, so it will be 0. So these are the base cases, and this is the entire recurrence, right? This is the entire recurrence. So let's try to write the code for this now. Let me know if you have any doubts. So we'll write it here. W is there, so int dp n plus 1 w plus 1 for int I equals to 0. Let's first take care of the base cases. I plus plus dp I0 equals to 0 for int I equals to 0, I less than equal to w, I plus plus dp 0 I equals to 0. These are the base cases, right? These are the base cases. Now we'll move to the recurrence. So for int I equals to 1, I less than equal to n, I plus plus for int j equals to 1, j less than equal to w, j plus plus, if weight of I minus 1 is less than equal to j. If we can take that item, in that case dpij will be the maximum of dp. Either we don't take it, so I minus 1 j, or we take it, right? If we take it, it will be I minus 1 j minus weight of I minus 1 plus value, right? So the value of I minus 1. Here we have one based indexing, but the array is 0 based, so that's why I minus 1. Else dpij equals to only one case we cannot take it, so dp I minus 1 j, and finally we can return dp n and w. So this is the answer to our problem. Let's run this. P3 is coming, so let's submit this. Okay, so this is also working. Let me know if you have any doubts. So we are done with both the problems for the day. Before I come into doubts, let's quickly discuss the homework that I want you to solve. And you should definitely try to solve these questions because again they are DB questions and very important ones. The first is longest consecutive subsequence. It is basically the, I think it is the given an array of positive integers, find the length of the longest subsequence that elements are consecutive integers. The consecutive numbers can be in any order. So basically consecutive subsequence means what is the longest consecutive, like 2 4 5, that's there. 1 1 4, hence 6 numbers form the longest consecutive subsequence. Okay, 1 2 3 4 5 6. Okay, so you have to take from can be in any order. Okay, they can be in any order. So what is the longest subsequence? This I again, like this is basically like what you have to do is you have to find what is the maximum consecutive subsequence, and the numbers can be in any order. For example, here 1 2 3 4 5 6 is present, 7 is not present, so it is 1 2 3 4 5 6. Here also we have 1 2 3 4, that's one. So 1 2 3 4 is the largest subsequence, so you have to return 4. So this is the first question. I think it can be solved without DP as well, but definitely check it out. Second is maximize the cut segments. This is a DP question definitely. Given the integer n that denote the length of the line segment, you have to cut the line segment in such a way that the cut length of line segment each time is either x, y, or z. Each x, y, z are integers. After performing all cut operations, your total number of cut segments should be maximum. So you have a line segment, you can cut it in multiples. You can either cut it in length of x, y, or z. You have to cut multiple times. What you have to ensure is the number of cuts is maximum. So how many cuts you can make? Third is the maximum length chain. You are given n pair of integers. Each in every pair, the first number always smaller than the second number. So the pairs are always like first number is less than the second number. A pair CD can follow another pair AB if B is less than C. Chain pairs can be formed in this fashion. You have to find the longest chain that can be formed from the given set of pairs. Right. So this question is also an interesting, good question. You can definitely try this out. And finally, we have the partition equals subset sum. Problem, time and space complexity both are n into w. Yes, I'm coming to that part. Sorry, I forgot to discuss that. Given an array ARR of size n, check if it can be partitioned into two parts such that the sum of both the parts are same. So you have to partition the array into two parts and such that the sum of both the parts is equal, right? So for example, 1 5 5 and 11, both the parts have a sum of 11. So these are the questions. Again, longest consecutive subsequence, maximize the cut segment, max length chain, partition equals subset sum. So these are the questions for your homework. Let's quickly discuss the space and the time complexity. So again, like it's very simple here. The space complexity, what is the space complexity? N into W, only one array. Time complexity, we are running a nested loop of n into W. So the space and the time complexity will be both n into W. So you are right, it's n into W. Similarly, for longest common subsequence, it will be n into m, right? X into y. X into y space, and here also x into y time complexity. Alright, so that's all I have for today. Thank you guys for joining in. Yep, I hope that you don't have any more questions. So thank you guys for joining in, and I'll be seeing you this Wednesday. Bye.